Okay, so the last time we went over surfaces, we did this operation called Isotrim. And what this allows us to do is actually just define a quad-shaped territory along our surface, and then to pull it out as its own little individual, it becomes a surface on its own, right? So we're extracting just a little piece of this surface, as you can see here, highlighted in green, right? And so we did that with the isotrim. What that requires, first of all, is a surface that you want to sample from, and then a two-dimensional domain. Okay, and so remember, this is what we're doing. We're giving it a minimum u coordinate and a maximum u coordinate, right? Sort of the longitude lines, and then minimum and maximum v, right? In other words, two latitude lines, and then the region defined inside of between those two longitude and between those two latitude lines, right, is a quad-shaped surface that we're sampling. Okay, and so really quickly, we're going to go ahead and do this over, but we're going to do something really kind of interesting. Instead of plugging in one two-dimensional domain, we're going to plug in a whole list of two-dimensional domains. And so once we take a surface and we plug in a list of two-dimensional domains to sample to create a subset, we get a list of small surfaces out. So we get a list of subsets. Okay, and so what we're going to do is we're going to basically break up this surface into a checkerboard, right? And so each cell in our checkerboard, if you can think of like sort of cells of rows and columns, right, is going to be defined by its own domain. And so what we're going to do is we're going to create a list of domains in order to create that list of checkers, this little list of cells that we're going to break this surface up into. Okay, so we're going to still use this isotrim command, but I'm going to go ahead and delete it for now because we're going to do a few things different this time. Instead of just defining one domain here, as I've done one two-dimensional domain here, I've done with a couple of four sliders, right? A umin, umax, vmin, vmax. I'm going to do something else. First of all, I'm going to measure the two-dimensional domain currently of the entire surface that we have, that we're using. Okay, so to do that, I'm going to go to Maths tab and go to Domain Tools. And I'm going to say, divide the two-dimensional domain. Oh, come on, really? Snooze. Yeah, don't restart on me, please. Anyway, so back to this. Domain Tools, two-dimensional domain, divide two-dimensional domain. You can see it's divide domain. It has a little superscript there. So in other words, we're going to measure the minimum and maximum u and the minimum maximum v of this surface. And it just so happens, if I hold my cursor over this, it's 0 to 0.25 and then 0.3 to 0.7. Just kind of weird, honestly. I'm going to go ahead and normalize that. So I'm going to reparameterize the surface. I'm going to right-click on the surface widget that references the surface that I built in Rhino. I'm going to click and reparameterize. Now when I have my cursor over this, it says that the base domain of the surface is 0 to 1 and 0 to 1. So 0 to 1 in U, 0 to 1 in V as well. And then the next inputs it needs are the number of segments to divide that U 0 to 1 into, and then same with V, right? So if we take 0 to 1 and we divide that 10 times, we get 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, all the way to 0.9 and 1, okay? And so you can see here that it's taken basically a two-dimensional domain and divided it up 10 times in each direction. So 10 columns and 10 rows. It means we have 100 two-dimensional domains now, smaller domains that define a sort of checkerboard. Okay, and so all we've done really is done a lot of division with numbers. Now what we're going to do is, now that we have a list of these domains, we're going to use the isotrim tool just like we did before. And instead of plugging in just one domain by making it with some number sliders, now I have this list of domains. I'm going to go ahead and plug it in here. All right, and I'm going to go ahead and turn this preview off so we can see things a little better. I'm going to go ahead and turn this preview off in Rhino as well. Okay, and so now you can see, we should be getting 100 checkers, right? Sort of 100 cells, 100 smaller surfaces out of this larger surface, right? You can see all of the edges between them, right? So here's a cell, there's a cell, there's a cell, there's a cell, right? They're all adjacent to one another. We've basically just broken up the surface into rows and columns of quads. Okay, with that simple move, we're good to go. So now I'm going to do a few things based off of this. We're going to build on this from now. But does that? I hope that makes sense, right? So far, right? So what we've done is we've broken this larger surface up into smaller checkers, so to say. If we just use that checkerboard metaphor one more time. Okay, and so on each of these checkers now, I'm going to build a small parametric component. Let's say it has to deal with shading or something like that. Okay, so you can follow along step by step with this, and I'll be putting this this demonstration file online for you guys to also refer to. Okay, and don't forget at the end of the video, I'm going to give you some instructions for what to do over the weekend, but I'll talk about those in class as well, so there won't be any surprises. All right, so let's get on with it. What I'm going to do is I'm going to look at each of these surfaces, and so I'm just going to do this for one surface, but of course I'll be plugging in all of my surfaces at the same time, so it'll be doing the operations on all of these surfaces at the same time. I know that seems kind of confusing, but normally what I would do is I would take a surface and I maybe try to find its vertices, right? And then I'd be trying to like build some sort of component from the edges and the vertices and things like that. In this case, right, I'm going to be, instead of just using one surface, I'm going to be plugging in 100 surfaces. And so I'm going to be generating, let's say if I want to find the 4 vertices of this surface, I'll be plugging in this list of surfaces, and so I'll be generating 400 points. 400 edges, because all of these are 4-sided, right, etc. All right, so I just don't want you to get too confused when you start to see lots and lots of points all over the place. And all we're doing, right, is we're thinking about one checker at a time. And then we just happen to be doing this to all of the checkers that we have, because that's the whole point of streamlining this process, a nice workflow that Grasshopper facilitates. So I'm going to go to surface, I'm going to go to analysis, and I'm going to go to deconstruct BREP. Looks like an exploding BREP. BREP is just a fancy term for polysurface. So surfaces can also be polysurfaces. I'm going to go ahead and plug this in. So this does is this gives us, for the surface that we plug in, it gives us the face of the surface, right? So it gives us the edges of the surface, in this case 4 for each surface that we have, and also the vertices for each surface. So we have 4 corners or 4 vertices, right? Vertex points for each of these surfaces. And so what it's doing is it's generating a data tree. I'm sure you can see now as my cursor has moved over this output V, right? You see the 0, semicolon 0, semicolon 0 in brackets, and then 001, 002, all the way to 0099, right? So we have 100 of these items in our list here, right? 0010 all the way to 0099. That's 100 items. That's referring to 100 tree branches, each tree branch referring to one of these checkers, right? Because we have 100 little checker subsurfaces. And then for each of those, we have n equals 4. In other words, we have 4 vertices for each of these, right? So that's why when you multiply out how many branches we have and how many items are in each branch, 100 branches times 4 items in each branch, that's 400. It means we have 400 locally defined values. We have 400 vertices in all, okay? And it's the same with the edges here. I'm going to use the vertices to start with. And so if you think about this just for a second, I'm going to want to take the first vertex point from each of these 100 lists, and I'm going to want to connect them to another vertex in each of these lists. And so what I'm going to do is I'm going to go to my sets tool and go to list and pull out the nth item, right? This sort of find a specific item in a list. And what you can do is you can tell it, like, give it an index of 0, and that would pull out the first item in each of those lists. Or an index of 1 would pull out the second item in each of those lists. An index of 2 would pull out the third item in each of those lists, and so on and so forth. We only have 4 items in each of these lists, and that's not going to change because this is divided up into quads. And so what I'm going to do is I'm going to go ahead and pull out one of these notepads, change this to 0. I'll go ahead and resize this so it's a little easier to fit on here. I'm going to plug this in for the index number, right? So this is going to pull out the first item because I've set the index to 0. So if I plug in the vertices, you can see that this is a data tree. We could tell when I pulled my cursor over it. but we can also tell because the rubber band moving to the right now is dashed. And so I'm pulling out just the first item in each of these 100 lists. And so let's just double check. Yeah, so I still have 100 lists starting at 000 and then ending at 0099, right? That's the left-hand side of this list of items. On the right-hand side, now it says in each of these tree branches, right? Each of these 100 tree branches, I have one item each now. So I've pulled out the first item. That's good. I'm going to go ahead and copy both of these at the same time and paste. Okay, I'll go ahead and move this over so it's a little further out of the way. And I'm going to paste another one and paste another one. And so for this second one, I'm going to change the number from 0 to 1. I'll double click in this one and change the number from 2 instead of 0. And then this one, 3. Okay, now I've pulled out the first item from each of these lists for this one, the second item from each of these lists for the second, and the third item, right? I'm changing that index number each time, and then the fourth. Okay, and so let's just confirm this. If I wanted to do a diagrid, one way I could do that is by drawing a line between alternating vertices. I could actually just draw an X in each of these, right? And so what I want to do is make a line between the first point and the third point, and then a line between the second point and the fourth point. So let's go ahead and try that and just double check, make sure everything's working. Here are all my first points, let's say my top left points, and here are all my bottom right points. Ah, look at that, right. Okay, so it's matching these up, the item in the first tree branch with the item in the first tree branch in this one, right? And then the second item the first item in the second tree branch and the first item in the second tree branch of this one. So it's matching them up nicely because these are both trees and they have the same number of branches and the same number of items. Okay, and of course I can do that again. And look at that. Now we have a diamond-shaped. Wow, Lee, look at that. Now we're cooking. Look at that, diagrid, right? I'm not so interested in diagrid at the moment, to be completely honest. I'll go ahead and turn this back on, the preview of it. I'll go ahead and delete these lines. That was just to show you, okay? And so what I'm going to do, though, is let's say I'm going to start to draw a surface and along these. So let me start off by doing something maybe kind of simple, and then we'll start to modify it. Okay. What I'm going to do is I'm going to take 1, 2, 3 points, 3 of these points, and just draw a triangular surface for each of these cells. Okay, and so I'll do surface by 3 or 4 points. Where are they? There we go. It's called 4-point surface, but you can plug in 3 or 4 points. So let's go ahead and plug in this one to this one to this one. Aha. And look at that, right? It attached this point to this point to this point and created a triangular surface within that sort of triangle that we defined with these 3 points. That's handy. Okay. And so that's not all that interesting, to be honest. It's kind of boring, actually. And so, if I thought about this for just a minute, maybe there's a different way of thinking about this. Here's an idea. What if I projected outwards from the surface, and then I started to give this some sort of three-dimensionality? So it's almost here. So I'll do this, and I'll build it step by step, and we'll zoom in here just so we can see what's happening as I go along. Okay, so I'm going to go ahead and delete this. I don't really need it anymore. What I'm going to do is I'm just going to pick one of these points. Yeah, maybe this one. That sounds good. Yeah, why not? Okay. And let's see here. Let me think about this for a moment. I want to be able to project in the normal direction off of each of these surfaces. Oh, so that's interesting. If we need to find that information, what we can do is we can evaluate a surface at a UV parameter, right? So I'm going to go to analysis. I'm going to evaluate a surface. I'm going to plug in all of these faces. Okay. So now I have a set of surfaces. Oh, goodness. And so I have 100 surfaces. I need to plug in a UV coordinate. I still need to do that. And when I do that, I'm going to get a UV coordinate on 100 surfaces. That means I'm going to get 100 points, and it means I'm going to get 100 normals. And so let's just double check and see where this is at. Oh, you know what else I need to do is reparameterize each of these. There we go. Yes, yes. Oh, goodness, you can see that we also have that plane. So we have the tangential frames at each of these, and those are being drawn. Whew, goodness gracious. All right, I'm going to go ahead and just pull out the points, right? So I'm going to make a new widget with just these list of points, and that way I can just turn the preview off here so we can see a little better, right? Placing a point at a particular UV coordinate on each of these surfaces all at once. And as soon as I change the UV coordinate, all of these 100 points change the location, which is really kind of interesting, maybe. So we go ahead and put it at this corner, let's say right here. Yeah, why not? And so that's also giving me the normal direction. And so what I'm going to do is at each of these points, I'm going to build a line. Curve, let's see, starting point, direction, and length. So line by start point, direction, length. Each of these points are going to be a starting point. The normals are going to be here. Oh, interesting. And then the length, look at where the normals are pointed. They're pointed at the end. And inside, maybe that's what I want, but actually right now what I want is the outside. So here's what I'm going to do. I'm going to make a number slider for my length. Yeah. And then I'm going to double click it, and for the minimum I'm going to set it to like negative number, like -5 for the max 5. And I'll go ahead and now if I go in the negative direction, ta-da, it's going in the direction that I want, right? Yay. All right. Okay, and so with this point I need to find, or with this new line I need to find its endpoint. And I'll do that right now. Okay. All right, now bear with me. It's just a little bit of connecting the dots here. But what I'm going to do is I'm going to build a triangular surface from this point to this point to that point. And I'm also going to build a triangular surface from this point to that point to this point. Okay, and watch what happens as I go. I can go ahead and turn the preview off for this line. I don't need it anymore. Okie dokie. I'll go ahead and turn the previews off for a lot of these. So go back to my surface by 4 points, surface by 3 or 4 points really. And I'll go from here to this one to this one. Oh yeah, look at that. Okay. And then I'll go, let's see, I will pull out another one of these widgets because I'll make another set of these. And let's see, I went from here to here to there. So now I'm going to go from here to here. So this one to this one to this one. Ah, excellent. Oh yeah. Now, interestingly, since I'm using triangulation, I know that this is planar and that the other, each triangle is going to be planar. And this is very similar to the example I showed the other day in class, and that I've been showing as an example. And so one of the things I can do, right now these are all separate triangles, right? There's 100 here and 100 here. What's interesting is I can try to join those together and then flatten them out and unroll them. Oh yeah. So one of the things I'm going to, again, the logic built in here is that I've made these out of triangles, so they're gonna always be planar components, and then those planar components could actually be unrolled and unfolded back onto the XY plane. And then from there, I'm just a few steps away from laser cutting. Okay, so that'll be the next video. I'm going to stop it here for right now, but this should be your starting point. What I encourage you to do, you've probably watched this. You might have been following along, you might not have. Now, if you haven't been following along, rewatch and follow along as you go, and make this. Because what I want you to do from here on then is to begin to modify this as a starting point for your own component. So it doesn't have to get too complex, but I'd be curious to sort of see what you do for yours, right? You can just modify this one a little bit, right? So I'm curious to sort of see what you're thinking. And, you know, you can do this in Grasshopper, but honestly, if you get lost in Grasshopper, then sketch this out, right? In other words, pseudocode it, right? Sketch out that diagram showing, you know, a quad, right? One of these quads, and then projecting a line and, you know, placing some points and then how those connect up, right? In which case, you know, I don't care if you know how to do it in Grasshopper yet, exactly, or if you get lost here and there. We can't do anything in Grasshopper if you don't have a well-defined problem. And by defining that problem through sketching, I think it would be a lot easier, okay? So keep that in mind as you go. You can always sort of sketch things out to sort of try to keep things straight in your head. It's always sort of writing down that recipe before you try to execute it, okay? So I'll see you in the next video. We'll use this as a starting point in the next video, and what we're going to do is we're going to join all of these together, unroll them out into a grid, and then number each one, put a label on them. All right, I'll see you then.